Today we are doing chapter 5.1e, day 2, relations and functions. Key idea: relation and functions. A relation pairs inputs with outputs. One example is a set of ordered pairs. So ordered pairs like x comma y, where you are going to pair the input, which is x, with outputs with y. A relation that pairs each input with exactly one output is a function. The domain of a relation is the set of first coordinate, which is x values. The range is the set of second coordinate, which is y values. The members of the domain can be called inputs, so x values are called inputs, and the members of the range can be called as outputs, so y values are called outputs. So are the following problems are function? Explain why or why not. So for number 1, you can see that the domain, there are x values listed here, and the range, which are y values, listed here. Each each x value has exactly one y value, so it means this is going to be a function. So the reason is that each x value or input exactly has one y value. For number 2, we have input as a, b, and c, and output are 1 and 5. Here x value has two different y values, so this is not going to be a function, so it's not a function because x has two y values, so it means it's not following the definition that each input has exactly one output. For number 3, it is going to be a function because each input has exactly one output. For number 4, this is not a function because here you can see this medium cheese pizza has two output values, so not a function. X has two y values, so one x has two different y values, then it's not a function. For letter 5, so number 5, it is again a function because y can have, so y, this is 12, can have two different x values, but x cannot have two different y values. Number 6 is again a function. All the x values have only one y value, but here y can have 3 different x values. It's still a function. Example number 1, determine whether relations are function. So each input has some output, so it means they are relation there. We want to see if each input has exactly one output, then it's going to be a function. For letter A, each x values is different and has different y values, so it's certainly a function, so this is going to be a function. No x value has two different y values, so each input has exactly one output. For letter B also, this is going to be a function. Each input has exactly one output. So each x value has exactly one y value. If you talk about the last question here, input is -2, -1, 0, 0, 1, and 2. So this 0, one x value has two different y values. So this is not going to be a function. It's because of this. So now we are going to discuss the key idea for the vertical line test. A graph represents a function when a vertical line passes through no more than one point. So for example, if you look at this example right here, if you draw a vertical line anywhere on the graph and it passes through only one point, in this case it's passing through one point, then it's going to be a function. So it's going to be a function, yes. Why? Because passes through, so the line passes through only one point, so it's going to be a function. Here it's passing through 2 points, or cutting at 2 points, so this is not going to be a function. It's not going to be a function because the vertical line cutting at 2 different points. Example number 2, using the vertical line test. Determine whether each graph represents a function. So you're going to use the vertical line test. It means you can draw a line anywhere on the graph and see if it's cutting at, so straight line, if it's cutting at 2 different points. In this case, it's cutting at 2 different points here. So it's going to be not a function because it fails the vertical line test. So vertical line test fails. In this case, you can draw a vertical line anywhere on the graph, a straight line, and it should cut on only one point. In this case, it's cutting at only one point, so it's yes. Vertical line test pass. Similarly, for letter C, I graph 2 lines anywhere on the graph and it is cutting at only 1 point. So yes, it's a function. Vertical line test pass because it's cutting at only 1 point. Here again, you can graph a line and it's cutting at only 1 point wherever you graph the line, so anywhere on the graph. So you can graph anywhere on the graph a vertical line and it cuts at only 1 point, then it's going to be a function, yes, because vertical line test pass.